Hi everyone, I am Merve. I prepared a lesson plan about ratio. The topic is from the 6th grade curriculum and I decided to use the 6th graders as my grade level because the students in the 6th graders learn this topic for the first time at the curriculum. So here is my objectives. My objective is using the ratio language to describe a ratio as a relationship between two quantities. For example, I give an example, the ratio of wings to beaks in the birdhouse at the zoo was 2 to 1 because for every 2 wings there was 1 beak. Then I also use multiple representation of ratios such as this one, and the second one is this one, and the third one is the fraction representation. And here is my materials. I used whiteboard as an online. I used colorful board markers, and I used a GeoGebra tool and a sketchpad, and as a video recorder I used Bandicam, and I record the lesson actually by mistakenly for seeing how it goes, and so I took screenshot from it and I pasted here, and as a launch I give the definition of ratio as a comparison of two numbers by division, and then secondly I give the definition of ratio again as a relationship between two quantities by division. Then I state the difference between ratio and the fraction because I really wanted to do that, because there can be some misconception in the minds of the students that the ratio is the same meaning with the fraction. However, their representation can be the same, but the way we use it different. We can write the ratio as a fraction, but in the fraction 1 over 2 has a different meaning, but in the ratio 1 to 2 has a different meaning. So I really decided to use this topic as my video record, and I explained it. Secondly, I focused the meaning of terms for each one, because these equivalent ways of stating ratios are the heart of the understanding the structure, and it separates the topic from the fractions in the way that we used. I also explained why we use the division to represent the ratio. I tell them to see the simplest form of the quantities in an easy way. I connected with the fraction concept because we can simplify the ratio and we can enlarge it. So this is also an important interference in the minds of the students. And then I write 3 different representations of ratio. Then I passed my first question. As an investigation, I discussed the color of the paints in the A and the B. Let me explain the first question briefly to you. Mark wants to paint his houses, and he mixes 2 boxes of green paint and 6 boxes of white paint to paint the first house, and he takes 4 boxes of green paint and 12 boxes of white paint to paint the second house. And I want them to compare the color of the first and the second houses. And I discussed how to reach the answers in the video. And I think this helps students to see the reasoning and proof as an important thing. So that's why I discussed the questions. To make clear this question, I used the GeoGebra tool, and I opened the GeoGebra tool. And this is the GeoGebra tool, and I choose 2 cups of green, mixture A. In the mixture A you can see that, and I choose 6 cups of white and I mix them. Then in the mixture B I choose 4 cups of green and 12 cups of white paint, and I mixture them. Let's see what happens. The color of the paints are the same, and I used different representation of this one. For example, in the tape diagram 1, they can see 2 cups of green and 6 cups of white, and you can see in the mixture B 4 cups of green and 5 cups of white. And my second representation is this one, tape diagram 2. This is the total cups of white. This represents the total of it. You can see the 2 cups of green in one representation and 6 cups of white in one representation. The total of it is 8. And the mixture B, you can see 4 cups of green and 12 cups of white, and the total of it is 16. I think the third one is more like the second one. I don't want to explain it to you. And I draw the boxes for both houses, and I asked the students work on a little bit. And I asked them to stop the video and think a little bit why this is happening. I asked the question, for every one green box of green color, how many boxes of white color we need? I asked this question to them. Also, I tried to direct them towards the green and the white boxes of paint that is used in the first house is doubled in the second house. I give this answer to them. Finally, we just enlarge it to get the same color is an important inference. And I ask them a question. I can leave it to them and I can answer it. I don't know. If you think Mark used 5 boxes of green paint to paint this third house, how many boxes of white paint would he need to use them make this house the same color as the other 2 houses? I can leave it. And I pass the practice questions 2, 3, and 4. And this is my second question. This is a basic question. Express the ratio of number of squares on the side to the number of triangles in 3 different ways. And the third question was, in the figures below, find the ratio of shaded area to the non-shaded area. And I also pasted a note. The ratio is written in the simplest form. And this is my fourth one. There are 12 girls and 9 boys in a classroom. This is also a basic one. Find the desired ratios accordingly. Find the ratio of number of girls to the boys. And the B is an important because it says the find the ratio of the number of boys to the whole class. And last one. I paste this one from the map as a question. I think this is also a nice question. After I solved this question, I ended my video. This is my last one. Thank you for listening.